Hi children, how are you? Today I'm going to discuss exercise 1.3 of real numbers. In the chapter real numbers, exercise 1.3 I'm going to discuss now. Okay, so let me discuss. Okay children, so exercise 1.3 question number 1, prove that root 5 is irrational. Prove that root 5 is irrational. So we are going to prove this root 5 is irrational from ninth standard and all. We have studied root 5 is irrational. So now we are going to prove this root 5 is irrational. And this question is very important. You may expect this question in the examination. Root 5 is irrational, or root 3 is irrational, or root 7 is irrational. One question will be there. You may expect that question. Okay, now to prove this root 5 is irrational, before that we have to understand what is coprime. Coprime means, see, I'm writing here 12 divided by 15. 12 divided by 15, not in simplest form. This is not in the lowest form. So 12 divided by 15 will be in the lowest form. When we divide, we can divide these both numbers by 3. Then we will get here 4 divided by 5. 5. Now this is in the simplest form. Now this is in the simplest form, that is in the lowest form. Lowest form means the HCF of these two numbers will be 1. HCF of these two numbers will be 1. That is the meaning of simplest form. Okay. So these two numbers are called coprime. If HCF of two numbers is 1, then we can call that as coprime. So no common factors other than 1. That is the meaning of coprime. No common factors other than 1. Okay. So let us move to the answer. So we have to assume here. So first we have to assume. So assume that we have to assume that root 5 is a rational number. Root 5 is a rational number. Is a rational number. Root 5 we can take as a rational number. And we have studied what is rational number. Rational number means a number of the form p by q. We have studied a number of the form p by q is called, where p and q are integers, is called a rational number. So we can write, if assume that root 5 is a rational number, then we can say root 5 is equal to what? Instead of p by q, I am taking here a divided by b, where a and b are, where a and b are coprime, where a and b are coprime. Once I told you what is the meaning of coprime. Coprime means no common factors other than 1. No common factors. No common factor other than 1. No common factor other than 1. Okay, so that is the meaning of coprime. So that means there will be no common factors other than 1. So here root 5 is equal to a by b, where a and b are coprime, we got. Now next, this we have to square on both sides. So squaring on both sides. So squaring, we will get root 5 square. Root 5 the whole square is equal to a squared divided by b square, or a by b the whole square. That is 5 is equal to what? 5 is equal to a squared divided by b squared. Now cross multiplying this, you will get 5b square. You will get 5b square. 5b square is equal to a square. 5b square is equal to a square. Keep it as equation number 1. 5b square is equal to a square. You can keep as equation number 1. Now 5b square is equal to a square means 5b square is equal to a square means what? This 5 is a this means 5 is a factor of 5 is a factor of a squared. This means 5 is a factor of, because 5 into some number is a square. 5 into some number is equal to a square. So we can say 5 is a factor of a square. Therefore, we can say this 5 is a factor of 5 is a factor of a also. 5 is a factor of a. 5 is a factor of a. We got 5 is a factor of a. Okay. Now mark it. Now see what is the meaning of 5 is a factor of a. When we reverse it, we know a is a multiple. A will be a multiple of 5. See, 5 is a factor of a means a is a multiple of 5. So we can take, let a is equal to 5 into some number, because a is a multiple of 5. So we can write a is equal to 5 into some number. So where c is some integer, or for some integer c. So we can write for some integer c. Okay, we can say, we can take, let a is equal to what? A is equal to 5c for some integer c, for some integer c. So for some integer c, we can take a is equal to 5c. This also you have to square on both sides. So squaring on both sides. So squaring, you will get a squared is equal to, see, by squaring this you will get what? A squared is equal to how much? A square is equal to 25c square. A square is equal to 25c square. Keep it as equation number 2. Now look this equation number 1 and 2. You can check equation number 1 and 2. Equation number 1 is 5b square equal to a square, and equation number 2 is a square is equal to 25c square. So both are equal to a square. Both are equal to what? A squared. So we can take this 25c square. So we can say from 1 and 2, or 25c square will be equal to what? 5b square. 5b square. 25c square will be equal to 5c square, because this 5b square is a square and 25c square is also a square. So you can say 25c square is equal to 5b square. Reason from 1 and 2, from 1 and from equation number 1 and equation number 2. So we got 25c square is equal to 5b square. Now we can cut this 25 and 5 we can cut. Then what we get? Then we will get 5c square is equal to 5c square is equal to b squared. 5c square equal to b square. Equation number 3. Now look here. Equation number 1. 5b square is equal to a square. We decided here, we proved here 5 is a factor of a square. See, 5b square is equal to what? A square. So we can say 5 is a factor of a square. So similarly, 5c square equal to b square, you can say from here 5 is a factor of 5 is a factor of b square. 5 is a factor of b square. So here 5 is a factor of b square. So you can say 5 is a factor of b also. Therefore 5 is a 5 is a factor of, therefore 5 is a factor of b. So 5 is a factor of b. Now look here, we got here we got here 5 is a factor of a. You can see here, from here we got 5 is a factor of, see, 5 is a factor of a. Here we got 5 is a factor of b. 5 is a factor of a and 5 is a factor of b. Once we told a and b are co-prime, that means no common factors. But here we got 5 is a factor of a, 5 is a factor of b. So we can say 5 is a common factor. So we can write here 5 is a common factor. Therefore 5 is a 5 is a common factor. 5 is a common factor. 5 is a common factor for both A and B. For both A and B. See, for A and B, this 5 is a common factor. So, this is a contradiction because we told 5 is A and B are co-prime. That means there is no common factors. They don't have common factors other than 1. So but we got here 5 is a common factor for both A and B, so we can write this is a contradiction. This is a contradiction. So this is a contradiction, so you can say therefore what we have assumed that is wrong. Therefore our assumption is wrong. Therefore what we have assumed, therefore our assumption is wrong. Therefore our assumption is wrong. Therefore our assumption is wrong. That means what we have assumed root 5 is rational, that is wrong means, so we can say root 5 is irrational. It is not a rational number. So root 5 is irrational. Root 5 is irrational. Okay, children. Now, next one, exercise 1.3, question number 2. Prove that 3 plus 2 root 5 is irrational. 3 plus 2 root 5 is irrational. See, always there will be in the board examination, always I see there in the text, in the question paper, they will give given that root 5 is irrational. Given that root 5 is irrational. But here we have only this one, prove that root 3 plus 2 root 5 is irrational. How to prove this one? So here also we have to assume this 3 plus 2 root 5 as rational number. So we can assume, so assume that assume that 3 plus 2 root 5 is rational. We can assume this as a rational number. We can assume this 3 plus 2 root 5 is rational. Then 3 plus 2 root 5, 3 plus 2 root 5 is equal to, we can take it as A divided by B. A divided by B. We can take it as A divided by B, where A and B are co-prime. Where A and B are co-prime. Co-prime, you know what is co-prime. Co-prime means no common factors other than 1. Where A and B are co-prime, or HCF of these two numbers will be 1. Okay, anyway, we got 3 plus 2 root 5 is equal to A by B. Okay, now you have to keep this 2 root 5 only in the left side and other all numbers, or only root 5 in the left side and other all numbers you have to transpose to right side. Okay, so I'm going to transpose it. First I am changing this 3 from here. I'm going to change here, so we can write 2 root 5 is equal to A divided by B. 2 root 5 is equal to what? A divided by B minus 3. That 3 you can transpose to right side, then it will be minus 3. 2 root 5 is equal to A by B minus 3. That is 2 root 5. That is 2 root 5 is equal to, you can cross multiply here. See, you can here give 3 divided by 1, then cross multiply, you will get A minus 3b, A minus 3b all divided by b, all divided by b, A minus 3b divided by b. Now this root 5 only you can keep that side, so you can write root 5 is equal to, root 5 is equal to A minus 3b all divided by, see here this 2 you can multiply with b. When you cross these 2 from here, when you transpose this 2 from left side to right side, it will be division. That means it will be with b. So you can write here 2b. So root 5 is equal to what you got? A minus 3b divided by 2b. Now see, you got root 5 is equal to a minus 3b divided by 2b. Now, since a and b are integers, you can say, since a and b are integers, since a and b are integers, since a and b are, a and b are integers, a and b are integers, you can say, since a and b are integers, you can say a minus 3b divided by 2b. A minus 3b divided by 2b is rational. This is rational. Okay. So a minus 2b, a minus 3b divided by 3b is rational. So we got a minus 3b divided by 2b is rational. So you can say, so root 5 is rational. Root 5 is rational. So reason again, we have proved 3 plus 2 root 5 we have assumed as a by b, where a and b are co-prime, as a rational number. Then 2 root 5 will be what? It is a by b minus 3. Then cross multiplying, you will get a minus 3b divided by b. So root 5 is equal to what? A minus 3b divided by 2b. Now since a and b are integers, this a minus 3b divided by 2b will be rational. Therefore root 5 is rational. But but we know, but we know, we know what? We know root 5 is irrational, but we know root 5 is irrational. Okay, so root 5 is irrational, that we know, but we know root 5 is irrational. Therefore our assumption is wrong. Therefore our assumption, what we have assumed, that is wrong. Therefore our assumption is wrong. Therefore our assumption is wrong, because we have assumed root this 3 plus 2 root 5 is rational. Then finally we got root 5 as a rational number, but we know root 5 is irrational. Therefore our assumption is wrong. That means what we have assumed, that is wrong. The meaning, what was our question? The question 3 plus 2 root 5. So we can say 3 plus 2 root 5, 3 plus 2 root 5, 3 plus 2 root 5 is irrational. It is irrational. It is not a rational number. So it is an irrational number. So 3 plus 2 root 5 is irrational. It is not a rational number, because we got, when we take it as a rational number, we will get root 5 also a rational number, but we know root 5 is irrational. So what we have assumed, that is wrong. Therefore we can say what? Therefore we can say what? Root 3 plus 2 root 5 is irrational. Okay, now let us move to next question. See here, exercise 1.3, question number 3. Now let us discuss exercise 1.3, question number 3. Prove that the following are irrationals. This very easily we can prove. First question, 1 divided by root 2. We have to prove 1 by root 2 is irrational. So we can assume that, first question I am doing, assume that what? 1 by root 2 is rational. We have to assume this as 1 by root 2 is rational. Then we can write this as in the p by q form, that is 1 divided by root 2 is equal to a divided by b, where a and b are coprime, where A and B are what? Coprime. Coprime means in the simplest form or in the lowest form. So 1 by root 2 is equal to A divided by B. A divided by B, where A and B are coprime. Now look here, 1 divided by root 2. How can we find root 2 from here? Take just reciprocal. Then you will get root 2 is equal to what? Root 2 is equal to b divided by a. Root 2 is equal to b by a. Now as usual, since a and b are integers, 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 we can say b by a is rational. B by a is rational. Therefore we can say root 2 is rational. Root 2 is rational. But we know, but we know that, but we know that, what we know, but we know that, we know root 2 is irrational, but we know root 2 is irrational. Root 2 is irrational, but we know root 2 is irrational. That means root 2 is an irrational number. So we, what we have assumed here, we have assumed that 1 by root 2 is rational. Then we will get b by a is rational, therefore root 2 is rational, but we know root 2 is what? Root 2 is irrational. Therefore what we have assumed, that is wrong, because we have to, anyway we have to get root 2 also irrational number. So therefore you can say, therefore our assumption is wrong. What we have assumed, that is wrong. Therefore our assumption is wrong. Therefore our assumption is wrong. Therefore our assumption is wrong. That is, this 1 by root 2, 1 by root 2 is irrational. It is not a rational number. It is irrational. It is irrational. Okay, now let us move to the second question. What is the second question? Second question, 7 root 5. 7 root 5. So let us do that one. 7 root 5 is irrational. So again, in the same way, we can take second question. Second one, assume that, assume that, assume that, what was the question? 7 root 5, 7 root 5, 7 root 5. So assume that 7 root 5 is irrational. 7 root 5, assume that 7 root 5, 7 root 5 is rational. We have to assume this as a rational number. We have to assume this as a rational number. Then you can say, then 7 root 5 is equal to what? It is a divided by b, where a and b are coprime, where a and b are coprime, where a and b are coprime. Okay, now root 5 you can keep here, other number, that means 7 you have to transpose from that side. So you will get root 5 is equal to this 7 you can cross here, then you will get a divided by 7b. Now as usual you can write, since a and b are integers, a and b are integers, a and b are integers, and b are integers, you can say a divided by 7b is rational. So a divided by 7b is rational. Therefore root 5 is rational. Root 5 is rational. So we got root 5 is a rational number. But we have proved, root 5 is irrational. So but we know, but sometimes it is given that, but we know in the question if they give, we can write it is given that. But here, but we know root 5 is what? Is irrational. Root 5 is irrational, but we know root 5 is irrational, therefore our assumption is wrong. Therefore our assumption is wrong. What we have assumed, that is wrong. For our assumption is wrong. That is the 7 root 5, that is 7 root 5 is irrational. It is not an it is not a rational number, it is an irrational number. So 7 root 5 is irrational. Okay children, now let us move to the question number 3. What is the question number 3? 6 plus root 2. Prove that 6 plus root 2 is irrational. 6 plus root 2 is irrational. So we are going to prove 6 plus root 2 is irrational. So here also, for third question also, we have to assume 6 plus root 2. Assume that 6 plus root 2, 6 plus root 2 is rational. 6 plus root 2 is rational. We have to assume this as rational number. Then we can write 6 plus root 2 is equal to 6 plus root 2 is equal to a divided by b, where a and b are a and B are co-prime, where A and B are co-prime, where A and B are co-prime. Okay, so here also we have to keep root 2 this side, this 6 you have to transpose to other side, then you will get what? Root 2 is equal to A divided by B minus 6. A divided by B minus 6. Okay, now you can give here divided by 1, then cross multiplying you will get root 2 is equal to what? A minus 6b. A minus 6b divided by b. A minus 6b divided by b. Okay, so root 2 we got a minus 6b divided by b. Now since a and b are integers, a and b are integers, a and b are integers, since a and b are integers, what can you say? Since a and b are integers, a minus 6b divided by b is rational. This is rational. This will be rational. Since a and b are integers, this will be rational. This will be rational. Therefore root 2 is also rational. Root 2 is rational. Therefore root 2 is rational. But we know what we know root 2 is irrational. But we know root 2 is irrational. It is an irrational number. Therefore our assumption is wrong. Therefore our assumption is wrong. What we have assumed, that is wrong. Therefore our assumption is wrong. Therefore our assumption is wrong. That means this root 2, this 6 plus root 2, 6 plus root 2 is an irrational number. 6 plus root 2 is irrational. It is not a rational number. 6 plus root 2 is irrational. It is not a rational number. Thank you children.